Hello everyone, and now I'm going to discuss about the communication protocol. Start from the introduction, working advantage, disadvantage, and application and final conclusion. Now, going to first PDF UART. UART is a universal asynchronous receiver and transmitter. Why it is named is the asynchronous. Asynchronous name because of there is no serial clock between device A and device 2. So therefore, this is the meaning of the asynchronous. Asynchronous means there is no clock is required to transfer the data one between the two devices. This is asynchronous. Receiver and transmitter. It can use two wires. First for transmitter data, another for receiving the data. Transmit the data from device A to device 2 and receiving the data from device 2 to device 1. This is the meaning of the receiver and transmitter. So this UART is a universal asynchronous receiver and transmitter. And first of all, this is the hardware communication protocol. So that's why using asynchronous serial communication between the device. So now we see here the serially data can be transferred like 111.111.0.0.0.0. This is the serially data can be transferred. It commonly found in microcontroller, microcontroller, uh, and peripheral device transmitter receiving the data. So now we see what is this and this. So data can be sent between the start and stop condition. What is the start condition and what is the stop condition? Now we are explaining in one by one point. When the status of data line go high to low, this condition is known as a starting condition. Then data line is go low to high state. That time this condition is called as a stop condition. Now it has one advantage. Advantage structure is very simple. Now we see only we can use only transmitter and receiver, two wires only. But disadvantage is there is no synchronization between devices. Synchronization means suppose this device sends some data and this device receives some another data. So take some time. Send the data and receive the data. Take some time. Once the device is sent, at that same time, device 2 is received. This is not possible. Not possible. That's why we can use the start and stop condition for achieve synchronization. But in case of this is not synchronization provided by a serial clock. So now disadvantage is no synchronization. Simple structure, there is no complexity, it's the UART. Now we see the small project. Now this is the microcontroller device, STM32, F401RE, and this is the UART. Now we see receiver, receiving pin, transmitter pin. Now see this diagram. There is two pins, PA9 for transmitter pin, PA10 is receiver pin. So PA9 is connected to the receiver pin, PA9. So now we see the PA9. PA9, PA9 here is transmitter, so PA9 is connected to receiver. Now we see PA9 is receiver and PA10 is transmitter. Simply we can connect it. Then now we see some basic parameter like baud rate is 96500, 9600. 9600. Why 9600? For serial if I want to serially data can be transmitted state, so that's why we can use the this baud rate 9600. Word length is 8 bit, so data can be sent on 8-bit data and period is none and stop bit is only one stop bit. Data direction either transmitter or receiver direction. Oversampling is 16 now. Then simply connected and write a program using the whole library. Then now we UART terminal run this program. Then this statement in case of that. So this the serial data can be transmitted using the UART communication protocol. Okay. But now we remember that UART and UART is a alternate function होता है. That is a push pull. Now the another protocol we need. So why we need another protocol? Because the first protocol is there is no synchronization. So if you achieve the synchronization, we can use the Another protocol name is the I2C. I2C means a inter-integrated circuit interface. So see here, we can use two wire. First is the serially data and another is serial clock. So we can provide here a synchronization. Previous case, there is no synchronization. So data can be transferred between the master and slave device. Master can, everything is controlled by the master. So here we can use so many slave devices, so many master devices. That's why we can say here the multiple master and multiple slave and acknowledgement we can use here in this case. Here only two words used STA and SPL. I2C is a bus interface between the microcontroller and serial I2C bus. Support only two mode SM and FM mode. SM up to 100 kilohertz, FM up to 400 kilohertz frequency, and I2C bus frequency increased up to 1 megahertz only. Remember these things. Now we can move another points. Now understand the working principle of the I2C. Then working principle. First we understood the start condition. Now see this diagram. I2C bus protocol. Then serial data line go high to low state. At that time, serial clock line will be high. So this is the start condition. When the serial data line go low to high, at that time serial clock line will be high. In both case, start and stop condition, serial clock line will be high, but in start condition, SDA line, serial data line go high to low means start condition, low to high means stop condition. First is MSB bit is transfer. MSB means most significant bit can be transmitted. The start condition and stop condition. Then after that, master can send the address to slave device. And once the slave device match this address, then respective slave device send a acknowledgement bit to the microcontroller and master device. And then after master send and receive the data. Uh, Otherwise, it cannot send and receive the data without receiving the acknowledgement. For every data frame, receive an acknowledgement and receive a send. Finally, a stop condition. Now I explain stop condition. What status line of serial data line is low to high. That means is the stop condition. Advantage is because here we can use the multiple master and multiple slave. So that's why multi-device supported low power consumption. Consumption power is low, and there is disadvantage speed issue. Speed is slow, complexity is more, and collision detection. Now move another protocol is the SPI. SPI is a serial peripheral interface. So this is the high speed communication protocol. Full duplex synchronized communication. So there is provide a series serial clock. So now we see the clock generator. So that's why this synchronized communication protocol. Full duplex. Full duplex means suppose this data at the same time send and receive the data same time. So that means of the full duplex. Follow the master slave architecture. One is the master device, another is the slave device. So that's why name is the master slave architecture. And master is the device that control the and initialize the communication, and slave is the response to the master device. And now we see four pins we can use: master out serial in, master in serial out, serial clock, and chip select. This is the 8-bit register, the another 8-bit register. First is MSB bit is transfer from master to slave device through the MOSI pin, and data is transferred slave to master device through the MISO pin, and then serially clock connected to the both 8-bit register for master and slave device. And then now we understood the working principle of the SPI. Then now we see serial clock, MOSO, MISI. These are the three pins are same for all slave device. Only one pin is different, the chip select. When the suppose this device selected means chip select line goes to low state. Suppose this device is selected, chip select line will be low state, other chip select device will be high state. Once the select the chips, then send and receive the data. Now we see the working master. First of all, generate a serially clock. Serial clock generate after selecting the slave device. Then transfer can occur for every clock pulse. Data transfer in full duplex. Meaning of the full duplex means send and receive the simultaneously between the master and slave. Then SPI offer करता है different polarity, clock polarity and clock phase. Now we explain through the diagram. Now we see clock phase will be 0. In this case, clock phase will be 1. Clock polarity will be 0 means data can be sampled in first clock edge and data can be sampled in second clock edge. This is the first clock edge, the second clock edge. So data can sample in second clock edge means clock edge will be 1. Data can sample in first clock edge means data can sample in first clock edge means clock edge will be 0. Clock polarity 0 1 means initially status line of become high. The clock polarity will be 1. Initially clock polarity status line will be 0, then clock polarity will be 0. This is the MOSO and MISO. The first is the MSB bit can be sampled in rising and this is rising edge, this is a falling edge. MSB bit can be sampled. The This is the capture step. NSS means chip select line. This will be low state. Now we see. Then here in SPI we can use 4 mode of operation: mode 0, mode 1, mode 2, and mode 3. And now we understood clock polarity and clock edge. When both are 0 0 means mode 0 mode, 0 1 means mode 1, 1 0 means mode 2, and 1 1 means mode 3. Now advantage high speed and full duplex data transfer. This is the advanced limitation. Here we can use more number of wires. So that's why this is the disadvantage of SPI communication. But instead of we can use for high speed communication, UART application like serial communication, console communication, embedded system, modern communication, medical devices. I2C we can use in IoT device, sensor integration, medical devices, and power management. And SPI now we see IoT device, sensor integration, medical devices, wireless communication. And what we do is the EEPROM, electrically erasable ROM. Okay, then first this microcontroller write some data to the EEPROM, and writing this data can be read through this microcontroller. We can use the two microcontroller. So through this, in this, in this data can be read on this address. This data is read this address. This data is read this address. Now can you know future communication of protocol like more data can be transferred quickly, more security, easier integration with different systems and devices. So conclusion is finally UART for now long distance communication, then I2C for short distance communication, and SPI for high speed communication. This is the and now we see long distance means point to point communication like a mobile phone. We can talk about only one to one talk. In broadcast communication means YouTube. One people is teach, then so many people are watching at the same time. This is the broadcast communication. Point to point means one to one talk means you are communicating. And now this is the complete. And thank you.